Welcome back to Algebra 1. Here I think things start to get really exciting and interesting because you're starting to learn how to solve equations in algebra. And so far we've learned how to do it whenever your equations require addition and subtraction. And now we're going to learn how to solve equations that require multiplication and division to solve. And you'll find out that once you know the general idea that I've been teaching you, it's all very simple. Now remember, when we're solving equations, when we have addition, the opposite of addition is what? Subtraction. And if you have subtraction going on, the opposite of that, if you need to get rid of something, is addition. So those make sense. So let me ask you a question. If you have multiplication in a problem, what do you think the opposite is going to be? The opposite of multiplication is going to be division. And if you have division going on in a problem, what do you think the opposite is going to be? The opposite is going to be multiplication, because multiplication and division are opposites of one another. So that's what we're going to use to solve all of these problems. And once you kind of get the hang of it, it's all very simple. Now, if you have the equation 8 times x is equal to 16, how do you think you would solve it? All right, so there's no addition going on here. You notice how in all the previous problems we had to add or subtract to get x by himself. Now we have multiplication going on where the 8 is being multiplied by the x. So in order to get rid of this x, we need to do the opposite, or get rid of the 8. We need to do the opposite, which means we need to do division. So the way that you write it is just like this. You rewrite the equation and say 8x, and you divide the left-hand side by 8, because we want to get rid of that 8. And on the right-hand side, in order to balance the equation, everything has to be done to both sides. Remember, you can do whatever you want to an equation as long as you do it to both sides. So here, I've divided the entire left-hand side by 8, and I've divided the entire right-hand side by 8. Now, what's going to happen on the left? You have 8 times x divided by 8. So you can kind of sort of ignore the x there and just sort of read it as 8 divided by 8 here, because this is multiplied, but then you're just dividing next, immediately after that. So the 8 is being divided by the 8 down here. What is 8 divided by 8? It's 1. Now you can strike through this to help you remember what's going on, but don't forget, they're not disappearing into empty space. It's just that 8 divided by 8 is 1. So the 1 sort of disappears because when you rewrite it, you just write it as x. That's all that's left. The 8's go away, they divide out. On the right-hand side, what is 16 divided by 8? It's 2. And that's the answer. So the x is 2. And notice if you take this value and stick it in here, for x, 8 times 2 is 16. So we choose very simple problems in the beginning, but that's basically what's happening. So you want to do the opposite to get x by himself. What if you have 3 times a is equal to negative 12? Again, you have the variable that you want trapped because something is being multiplied by it. Not addition or subtraction, but multiplication. So you want to do the opposite, which means division. So the way I suggest is rewrite the problem, and then you divide the left by 3 to get rid of the 3 and the right by 3. Now here, again, the 3's, we're going to do a strike through, but remember, they're not really disappearing. It's just that 3 divided by 3 gives you 1. So when you do that, only thing that's left is a, really 1a. There's an implied 1 right in front because of the division you did. There's really a 1 here, but we just write it as a equals. What is negative 12 divided by 3? Remember, we learned how to divide these numbers. 12 divided by 3 is 4, and since the signs are opposite, negative and positive, you're always going to get a negative sign. So the answer is negative 4. Now, if you take negative 4 here and stick it in here, 3 times negative 4, if you remember your rules of multiplication, gives you negative 12, so that's the right answer. All right, now, what are we going to do if we have a problem like 1/2 times b is equal to 4? 1/2 times b is equal to 4. Now, there's a couple of ways you can basically look at this. You can look at it as the fraction 1/2 being multiplied by b, or you can kind of look at it as division. What's really happening here is b over 2, right? So you want to do the opposite of it. So it's better to sort of think of this as division. It is 1/2 times b, but really it's b divided by 2 because these are multiplied together. So you want to do the opposite of that division, which is multiplication. So the way you would write it, another way you might see this equation, by the way, is b over 2 is equal to 4. These two things are basically exactly the same. So you can think of this as being division on the left. How are you going to get rid of that 2? It's going to be multiplication, multiplying both sides by 2. So you can write it as 1/2 times b multiplied by 2 on the left, and if you do it on the left, you have to do it on the right. And why do you do that? Because what's basically going to happen is here you have 1/2, and here you're multiplying by 2. And don't forget, if you actually multiply these together, the tops are going to be multiplied, so you'll have a 2 on the top, and then there's an implied 1 down here, which means you'll have a 2 on the bottom. So the way you typically see it written is you strike out and cancel the 2's, but really what's happening is since you're multiplying them, you have 2 over 2, which is 1. And so what you have is b on the left is equal to 4 times 2 is 8, and that's the final answer. So the trick here is to recognize that this is sort of like division, and you want to get rid of the 2 on the bottom by multiplying by 2. When you have, just like we had here, a 3 on the top and a 3 on the bottom, they divided out to give us 1. Here, when you multiply by 2, you have a 2 on the top and a 2 on the bottom, and they're going to divide out and give you 1, so they disappear. And so b is equal to 8. If you stick 8 in here, 1/2 times 8, I think you would agree is 4. So that's the final answer. What if you have negative 1/10 times r is equal to 5? Now again, you need to start to view this 1/10 as kind of like division. It's like r over 10. The 10 is on the bottom. That's what I want to get rid of. I want to get rid of that. How do I do that? I need to multiply, because this is a division that's happening right here. So I need to say the negative 1/10 times r, and I'm going to multiply by something. I'm going to multiply by, in this case, negative 10. You'll see why in a second, is equal to 5 times negative 10. Why did I multiply by negative 10? It's because ultimately I want to get r by himself. Since there's a negative sign here, when I multiply by negative 10, negative times negative will give me positive. So then the sign will disappear. The 10 on the bottom will cancel with the 10 on the top, and all I will have left is r, because the negative here times the negative here is going to give me positive, and the 10 divided by 10 is going to give me 1. So the r is all that's left on the left, and on the right, 5 times negative 10 is negative 50. And that's the final answer, negative 50. All right, now we're going to move on and just solve a couple of additional ones. What if I have 5 is equal to 5y over 3? So now it's written a little bit different, you see, 5y over 3. Now I want to get rid of everything on the right-hand side that's not y. I want y to be all by himself, okay? So how can I do that? This might blow your mind the first time you see it, but basically, I'm going to rewrite the equation. 5 is equal to 5 times y divided by 3. What I can do is I can multiply on the right by, to get rid of the 3, I can multiply by 3, and to get rid of the 5 over here, I can multiply by 5. So basically I'm multiplying by that reciprocal. Remember that concept we talked about a long time ago? I multiply both sides by 3/5. Why do I do that? Because the 5 on the top will cancel with the 5 on the bottom, and the 3 on the top on the bottom will cancel with the 3 on the top. So the only thing I have left on the right-hand side is y. And on the left-hand side, I have to multiply this fraction, 5 times 3, and this is an implied 1 down here. So what I have is 15 over 5, when I do the multiplication on the left, is equal to y. And that means that y is equal to, what is 15 divided by 3? I'm sorry, 15 divided by 5 is going to be 3. And that's the final answer. Now, it's really important for me to point out a couple things to you here. You need to start getting in the habit in algebra of when you see a number or something on the top of a fraction and the same number on the bottom of the fraction, you need to start realizing that you can cancel and get rid of them. They don't disappear, it's just that 5 divided by 5 is going to be 1. So you can kind of always scratch through things that are in the top and the bottom. Here I have this in the top and also in the bottom, so I can scratch through it. That is why I multiplied by 3/5 to get rid of the top and the bottom at the same time. Okay, but I want to redo the problem, or at least redo part of it, to show you that you don't have to do everything all at once here. If I had the equation, I'll just rewrite it again. 5 is equal to 5y over 3. You don't have to do it all at the same time. For instance, let's say that I just wanted to get rid of the 3 first. I wanted to get rid of the 3. How do I do that? I have to multiply by 3, because this is a division symbol, dividing by 3. The opposite of that's multiplication. So I'm going to multiply by 3 on the left and multiply by 3 on the right. And if I do that, on the left I'll get 15, and on the right, what am I going to get? Well, this 3 is going to cancel with this one, so all I'm going to have on the right-hand side is going to be 5y. And then I look at this and I say, how can I get y by himself? Well, this is a multiplication, 5 times y. So in order to get rid of the 5, I divide by 5 here, divide by 5 here. And what does that do? The 5 cancels with the 5, and then over here, On the left, 15 divided by 5 is 3, and on the right, all I have is y. So the same answer. You see, it's doing exactly the same thing. So you can do it step by step. You can just get rid of the bottom thing first by doing that, and then you can get rid of the top thing by multiplying, or you can do them both at the same time, multiply the left-hand side and the right-hand side of the equation by the fraction 3/5, which does them both at the same time. You have freedom there. As long as you're, doing the same thing on both sides of the equation, you can multiply or divide anything you want to both sides of the equation as long as you're doing it to both. So make sure you understand these problems. We're going to solve lots of more of them as we go on into the next sections to give you lots of practice. But the same technique is going to apply to all of them. So make sure you understand these. Follow me on to the next section to practice those right now.